All right, let's do tangent. Arctangent, or tan inverse, is the trickiest one. And you'll see why in just a moment here. But it definitely takes a little more thought than the last couple did. And I don't mean that to scare you or anything, I just want to be frank about it. And you'll see why in just a second here. So this is what tangent looks like. I know we didn't spend time looking at what tangent looks like and graphing it, but that's what it looks like. You can see it also has a period because it repeats itself. But it has a different looking period because remember what tangent is y divided by x. Right? This is what tangent is. You divide the y divided by the x value, and so you get these vertical looking kind of periods instead of the flowing horizontal looking ones of sine and cosine. Remember that you also get asymptotes for tangent because tangent has a 0 or has an x in the denominator. So anytime the x value is 0, we get a vertical asymptote at that point. Right? So x values are 0 at minus pi over 2, pi over 2, 3 pi over 2. Those are all the places where the x value is 0, and so that's where we get those vertical asymptotes. Just trying to tie it back into the vertical asymptote section and things like that. Anyway, so when we're thinking about tangent, though, and tan inverse, it also isn't one-to-one, right? If we drew a horizontal line through this, it would touch each one of those pieces. And so just like the other graphs, we cut out one piece and make a one-to-one piece. And so we cut out the middle piece, and it would look like this, or the inverse would look like that. So if we cut this one and take the inverse, this becomes the inverse function. Right? If we kind of flip this one around horizontally around the line y equals x, it would look like that. But the main thing that we're talking about that I want to focus in on is that we're talking about the same interval as sine. Right? So we're talking about from minus pi over 2 to pi over 2. And so on the unit circle, that's again the right-hand half. Right? Minus pi over 2 to pi over 2. And again, sometimes we refer to this as arctangent or arc. And all these same properties apply as long as you're on the right interval or as long as you're thinking about these correct way. And you can see why these ones are a little bit more complicated because tangent isn't just the x value or just the y value, it's both of them. And so when you're trying to think about where it came from, you need to think about undoing fraction division, which can be challenging. So let's look at a couple. So again, we're doing the same kind of thing, right? If tangent takes a t value and then you divide the y and the x, if we're doing the inverse, we're trying to send that division of the y and the x back to where it came from. But it's a simplified version of that division, which is tricky. So in this first one, tan inverse of minus 1 over root 3, the way we think about that, just like the other ones, is we think, what t gives us tan of t equals minus 1 over root 3? All right, we're doing the same thing as we did in the last page, but now we need to think of dividing two things, right? Because tangent divides the y and the x. And I just want to be clear about this. I don't know if I put this up yet. This is all box 1 stuff. Have I said that? I haven't said that in a while, so I should probably say that out loud. Right? Box 1. This is from the very first trig page after the unit circle. Box number 1, I put many, many stars around it because it's super important. All this stuff is from box 1, and you can see this is where tangent is coming from, right? Tangent is y divided by x. So that's where we're getting this. Cosine is x. That's where we got that. Sine is y. That's where we got that, right? So it's all based on box 1. Sorry, I hadn't said box 1 in a while, so I figured I'd say that. So anyway, if we want to know what t gives us that, we need a t such that the y value divided by the x value will give us minus 1 over root 3. All right, so that's tricky. And so the 1 isn't really telling us very much. But the root 3 is telling us something. And the way I think about this is that the root 3 is in the denominator, right? And x is in the denominator. And so whatever we choose for x should have a root 3 in it. Does that make sense? Let me write that down and let me know if that makes sense. So since square root of 3 is in the denominator, then the x should have a root 3 in it. And what type of points have root 3? What goes with root 3? Nothing just has root 3. It's root 3 divided by 2. So x should be some form of root 3 over 2. Right? Because that'll put the root 3 in the bottom. All right, you with me on that? So if x is root 3 over 2, what goes with that? What's the y that goes with that one? 1/2. Good. So if x is plus or minus root 3 over 2, then we know the y that goes with that one is plus or minus 1/2. Again, from that page that has those 3 points you really need to know. And so what we know right now is that our point is going to look something like root 3 over 2 comma 1/2, but we don't really know pluses or minuses at this point. But we can reason which it should be, right? If this is negative, right? 1 over root 3, negative 1 over root 3 is negative. If we want to divide these two things and get a negative number, what does that mean about the signs of each one?
One has to be positive.
One's got to be positive and one's got to be negative. Good. Because if they're both positive, then you divide them and they stay positive. And if they're both negative and you divide them, then the negatives cancel and it's positive, right? So we need one to be positive and one to be negative. So let's write that down. So we need 1 greater than 0 and 1 less than 0. And so there's a couple places on the unit circle where that happens. Maybe I've got some space to write in a unit circle here. What type of points give us this root 3 over 2 comma 1/2 type things? Is it pi over 3, pi over 6, pi over 4? Pi over 6 ones do. And if one's positive and one's negative, that means it's either this point, that would be a negative x and a positive y, or this point, that would be a positive x and a negative y. And so our options are, well, there's lots of options, but the straightforward ones are going to be 5 pi over 6, or maybe minus pi over 6. And we want to choose the one that's between minus pi over 2 and pi over 2. And so which one is that? The negative one. Very good. So we need RT to be between minus pi over 2 and pi over 2. And so we choose minus pi over 6. And so just as a final answer then, I will squeeze in my final answer right here. Tan inverse of minus 1 over root 3 is minus pi over 6. Right, the tangent ones obviously are the most tricky, right? Because you have to consider undoing fraction division where things have already been canceled. And that's a lot of writing. Again, I don't need to see that writing, but it'd be helpful if you gave me some idea what you were doing, so that if you screw up along the way, I'm happy to give you some partial credit, and lots of it. And also notice that this makes sense, right? If we divide, so it's this point, right? It's this point, and so it's going to be positive root 3 over 2, negative 1/2. And if we divide those two things, we would get minus 1 over root 3. You can always double check your answer on these ones. So that actually makes sense. Questions? Yeah.
I have a question. So what about 9 pi over 6? You know, like, does that not count as an option?
So 9 pi over 6,
That's where the,
that would be over here, right? Is that right? 9 pi over 6 is 1, 1 and 3. That would be right here, wouldn't it? Were you thinking about 1 over here? This one. Oh, this one. This one. This one. Oh, so 11 pi over 6 would put us right there. That's an okay answer. It's just not on the right interval. So thinking about this, minus pi over 6 was our answer because minus pi over 6 is like right here somewhere. 11 pi over 6 is an okay answer, but that's over here on this piece of the graph. It's just on a different piece. And so it would be a good answer. Like, it's not a bad answer. You would get a lot of partial credit for that, like 90+% of the partial credit. It's just thinking about a different piece of the graph. But yeah, that would be okay if you did that. It would be really not a big deal. I don't want to say like it's completely correct because we're trying to stay on the right piece, but it's very, very good. You're thinking about it correctly. You picked the right number. It's just a little bit on the wrong piece. Do you see what I'm saying about that?
yeah. It's like it's negative pi switching.
Yeah, we want it, exactly. We want it to be between minus pi over 2 and pi over 2. And what you did is just, or what, not what you did, but what you're suggesting is just a piece that's just on this piece. It's literally the same exact height, right? It's like the same sort of rightness and correctness in some sense. It's just on the wrong piece of the graph. That's all. Yeah?
When you graph inverses of these functions,
Yep.
are they always like just a piece or like a period of it?
Yeah, when you graph the inverse. So that's a good question. Why can't we graph another piece of this?
Not one.
No, 1-to-1 is this way. If we stacked another one on top of this like this, it would be 1-to-1. It wouldn't be, it would fail the vertical line test. What does that mean?
It's not a function.
It's not a function. And so you can't, in order to plot something, you need to type it into a calculator or something, right? And so we can't plug something into the calculator that's not a function. So yes, it's only one piece when we graph them, yeah. Good thoughts. Other questions or comments? Right, this is tricky stuff. I appreciate the comments and the questions. Appreciate your thought process. Let's do another one. Got good time here. Okay. Tan inverse of minus 1. Let me do the last one, actually, and save that one for you. Let's do tan inverse of root 3. So the way you want to think about this, very similar to the last one, right? You want to think, what do I need to plug into tangent that will give me root 3? Right? So we think tangent of what equals root 3? And so tangent, you divide the y by x, right? So we do, okay, we need to divide x and y and somehow get root 3. And what I want to point out, kind of the key part of this one, is realizing that root 3 is in the numerator. It's like root 3 over 1. And so that's telling us something about the y value then, when we recognize it like that. Does that make sense? And so based on this, we know that the y value needs a root 3 in it. And so that means y needs to be plus or minus root 3 over 2. All right, so it's recognizing like numerator versus denominator, and that tells you one of the two values. And then once you have one of them, we know how to get the other one because they're in pairs, right? They're always associated with in a pair. So if we know y looks like this, oh, this is actually very similar to the last one, right? If y looks like this, what does x look like? It's got to be, yeah, some version of 1/2. But this is an opposite situation to the last one in that root 3 is positive. Right, so root 3 is positive. And so if we're going to divide two numbers and get a positive value, they either both need to be positive or both need to be negative. Right, and so if since root 3 is positive, that means we need both the x and the y value to be positive, or they both need to be negative. Again, so that when we divide them, we get a positive number. All right, so where does that happen on the unit circle? Where are both the x value and the y value positive, root 3 over 2 comma 1/2, or both negative, root 3 over 2 comma 1/2? First and third quadrant, and this is still a pi over 6, right? So it's going to be either right here at pi over 6, or right here at whatever, 6 or 7 pi over 6. Those are our options.
Would it be pi over 3? Because the y is square root of 3 over 2.
Oh, I'm sorry. Yeah. I got confused there. Thank you for pointing that out. Yeah, the y value is root 3 over 2, and so it's not pi over 6, it's pi over 3 type. Thank you. Right. And so it'd be the same kind of general areas, but pi over 3 instead of pi over 2. I mean pi over 6. So it'd be like a little bit further, so it'd be pi over 3, or 4 pi over 3. Yeah. Good catch. That should not be there, it's just part of that. Does that make sense? And we want to pick the one that's between 0 and or minus pi over 2 and pi over 2. So which one of those two is on that interval? Yeah, pi over 3. So we need t to be between minus pi over 2 and pi over 2. And so that means we choose pi over 3. And so our answer, tan inverse of root 3 is pi over 3. All right, give the second one a try. Are there questions about this one first? Try the second one. Let me actually, I don't know, maybe this one's more confusing. I thought it was less confusing, but now that I'm looking at it, I'm like, maybe this one's a little more confusing. Let me set it up for you and then ask you to finish it at least. So we want our tangent, we want to plug in something into tangent and get -1, right? And so that means when we divide y by x, we want to get -1. And so what does that mean about the relationship between y and x? If we want to divide two things and get -1, we know a lot about them. What is it? They need to be the same number, but different signs. Yep. And the other way to think about that is we can multiply this x over to the other side, and this implies that y has to be -x, right? So literally the same number, but opposite signs. All right, so now that you have that information, you should be able to think about this one. So think about where that happens. Where are the numbers the same? The x and the y values are the same, but one's positive and one's negative. All right, think about what that is, where that is on the unit circle. Someone just say out loud, what's the type where the two numbers are the same? Pi pi over 4 type ones. I think I heard someone say pi over 2. Pi over 2 have 1 and 0 pairs, right? Either minus 1, 0 or 1, 0 or something like that. So pi over 4 are the ones that have root 2 over 2, comma root 2 over 2. So it's some pi over 4 type. And we want to think about just the one on the correct interval. Right, where 1's negative and 1's positive. So do you agree that it's got to be one of these 2 points? These are the 2 places where the x and the y values are the same but opposite. Same but opposite signs, I mean. And so maybe it's like, it could be 3 pi over 4, or maybe it's 7 pi over 4, or minus pi over 4, right? There's lots of different coterminal options. And so what's the one that we want? Negative pi over 4 is the one we want. So our options are t equals 3 pi over 4, or 7 pi over 4, or minus 5 pi over 4, or minus pi over 4, right? Dot, 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 etc. There's lots of options. We want to pick the one that's between 0 and, minus pi over 2 and pi over 2. And so this is the one that's between those two. This is the one that's in the right interval. And so we choose that one. And so our final answer then, tan inverse of minus 1 is minus pi over 4. Questions? Okay. Let's wrap this up. The ones on the right on this particular page aren't too tricky, I don't think. So we have these same kind of properties, the same cancellation properties in the previous page. We just need to make sure that x is in the right interval. That's all. And the first one's really nice, right? What does this mean? Does anyone know what this means? X. Yeah, all real numbers. This means any real number. In other words, x comes out in this situation every time, no matter what, as long as what's in there is a number. And so like on the second problem, that's an example of this. Tan of tan inverse of 9,846 just comes right out, 9,846, because that's a real number. And so we can use that one no matter what. And that's because tan inverse has a range of anything, right? If we look at this graph of tan inverse, it goes forever in both directions, right? It goes forever in the right, it goes forever to the left. And so we don't have to restrict ourselves because you can plug anything into those. But the other one, we are restricted because we're only thinking about this middle piece, and this middle piece has a restricted domain. That's why we need to be between minus pi over 2 and pi over 2 in the second one. But this first one is easy, right? So is minus pi over 4 in the right interval? Is minus pi over 4 in minus pi over 2 to pi over 2? Question mark? Yes, it is. And so the answer to this one is just minus pi over 4. So that one wasn't too bad either because it was in the right interval. All right, last one. This is the same as the first type example, but the problem is 4 pi over 3 is not in between minus pi over 2 to pi over 2, right? So 4 pi over 3 is not in the correct interval. And so let's just figure out a coterminal angle that is in the correct interval. So let's think about where 4 pi over 3 is. 4 pi over 3 is one step of pi over 3 past pi. So that's down here. And tangent divides the x and the y value, right? And so this spot right here has a negative x and a negative y. And so we want some value that then when we divide the x and the y is going to be positive. So what's something that's, I think I used the word coterminal before, I didn't mean that. I'm talking about what is something that will give us the same value of 4 pi over 3, but that's on the right-hand half of the unit circle. Pi over 3, right? This one. They're going to have the same points, except the bottom one, 4 pi over 3, they're both negative, and the pi over 3, they're both positive. But when you divide the two, you'll get the same answer. And so pi over 3 is just as good of an answer as 4 pi over 3. And so what we can say for this one is that tan inverse of tan of our original 4 pi over 3 is the same thing as tan inverse of tan of pi over 3. And pi over 3 is between minus pi over 2 and pi over 2, and so we can use that one. And so this just equals pi over 3, since pi over 3 is on the right interval. Whew, I feel like that was a lot. Can I answer any questions about this page at all? Okay, yeah, so we've done enough trig, so now we can start using it to do interesting things, and this is the first page of that. This page is all about how we can learn different pieces of sizes of circles using some trig information, and this is going to be a good link to converting between degrees and radians if you need some review on that. This is a good section for that. And so, because quite frankly, the formulas are pretty easy, and so what I'm going to try to focus on during this particular talk is converting between degrees and radians, and giving you some intuition about how to think about that. So the first equation that we're going to look at is this one right here, S equals R theta. And so S equals R theta refers to this picture right here, okay? And so we see that the radius is R, the length of the outside of the circle is S, and the theta value is on the inside here. And you can see what I'm underlining is that theta is measured in radians in this particular function, and this particular equation, I mean. And so when we use this equation, if we want to use this equation, we need to make sure that whatever our theta value is, it's in radians. And so that's like the only kind of tricky part about this page, is that you just need to remember that theta is measured in radians. And while we're talking about that, since it'll come into play in a second, I might as well just say something else about radians that we haven't quite made clear yet. Maybe I'll write it up here. Radians is not, I've been calling it a unit maybe, or maybe I've used the word unit. It's technically not a unit in the same way that like meters or degrees or, I don't know, any of those other things. Fahrenheit, kilometers squared, like those things are units as in they're a measurement. We use the word radians to differentiate between the inside of an angle like this that I'm pointing to right now and the outside of the angle on the unit circle. And so you'll see in a second that we need to make sure theta is in radians, but it's not actually a unit. And you'll see what I mean in just a second. So maybe I'll just write that down first though. So just note, radians are a label, not a unit. And so you'll see in a second what I mean by that, but you may just want to write that down so it makes more sense later. So radians are a label, not a measurement. Okay, or not a unit. Let's look at the first problem. So anyway, if we want to, this equation relates S, R, and theta, right? S equals R times theta. And so if we're given a question that looks like this, right, we're given R equals 5. We want to know the theta value, and we're given that S equals 10. And so this is our S. If we want to use this equation, we can just plug these two numbers right in there, and we see that S equals R theta, and so that means 10 equals 5 times theta. And so since we're measuring theta in radians, this ends up being theta equals 2 radians. And I mentioned I want to just kind of focus in on converting it. If we're interested in knowing this value in degrees, remember this is from the video lecture that I put up when I was away that day. If we want to figure this out in degrees, we take our 2 and leave some space here. I'm going to fill some stuff in, but we multiply it by 180 over pi. And let me just, I've said this before, and I've said it in the video at least, but let me just sort of say it now that I'm in front of you, how you can remember 180 over pi. If we want this to be in degrees, we eventually want this to equal something degrees, right? This is the degree sign, right? And so the way you can think about that is pi comes with the label radians, 180 comes with the label degrees, and 2 already has the label radians. And so you can see that when we divide by this pi radians, it cancels this radian value as well, that label, and we'll be left with something that has a degree, which is what we want. Right? And then 2 times 180 is 360, and so this is the same thing as 360 over pi degrees. And so the second thing I want to point out, which seems to be a small confusion for people still, is don't forget that pi is a number. We just leave it as pi a lot of the times, but it's 3.14159, blah, 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 right? So this, we could actually divide 360 by 3.14, blah, 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 and get an approximation for this. This is about 114 degrees. And I want to point that out because this kind of relates back to that homework question that talked about it gave you some angles or some radian values, and it wanted to know whether the value was obtuse, acute, or a right angle. That was a homework question from last time. And what I think the confusion of that question is that people are forgetting that pi is a number. And so if this is 0 on the unit circle right here, and we know that this is pi halfway around, that means this is 0, and this is about 3.14. Right? That 3.14 is pi. And so this picture makes sense because 2 radians is less than 3.14, but it's also bigger than pi over 2, right? Pi over 2 would be half of 3.14, which is like 1.8 something. So right here is like 1.5 something, 1.5-ish. 1.57, I guess. So if that's 1.57 because it's pi over 2, and that's pi, 3.14, then 2 is right in between them, right? And it's a little bit closer to 1.57 than it is to 3. And so I just wanted to remind you that pi is a number, and that's how you thought about that homework question. Were there questions about that one? That homework? I was emailing some people, so I thought I'd just say that out loud. So I just said a lot of things. Questions about any of it? The equation, converting to degrees, pi. All seems all right. Okay, so that one wasn't too bad. The next one's also not bad, but we just need to do a little bit more thinking. So this is the same kind of question, except we're not given a picture. So let's just draw the picture. If we have a circle like this, we're saying that the angle is 45 degrees and the radius is 10, and we want to find the length s. And so that would look like this then. 10 meters, and we want to figure out what s is. And again, the one time that people often misuse this equation is because you forget that theta has to be in radians. And so we're given it in degrees, and we need to think about it in radians instead. And 45 degrees is one of the easy ones because it's halfway between 0 and 90. And the radian value that's halfway between 0 and 90 is pi over 2. I mean pi over 4, excuse me. But just in case we didn't know that, we could calculate it anyway, right? So we need 45 degrees in radians in order to use this equation. And so we take that theta value, and we're going to do the opposite of what we did before, right? Before we went from radians to degrees, and so now we want to flip this 180 over pi and make it pi over 180. Right, so we take 45 degrees and we multiply it by pi radians over 180 degrees. And you can see why this makes sense, right? We want to end up with something that says something radians, because we're trying to convert degrees to radians. And you can see that these two degree values will cancel, and this radian value will carry over to the answer. Right, so that's, again, how you can remember these formulas. And so 45 goes into 184 times, and so this ends up being pi over 4, like we said before. You guys see what I'm saying about the formulas? It's just like anything else, I mean, in math, but specifically in the trig section, if we just kind of understand why this stuff works, we don't have to memorize things, because there's a lot in that section. If we just understand how it works and the relationships, they just like make sense, and they're just kind of in our head, and we can reproduce them. Rachel?
Maybe I'm missing something. I'm a little confused because why wouldn't you use that formula solely?
We will. We're going to use it, but in order to use this formula, theta needs to be in radians.
Okay.
And so we're just taking 45 and putting in radians first, and now we're ready to plug it into the formula. And so we want to find s, right? So s equals theta times r. Theta now is pi over 4. R is 10 meters. And so s ends up being, we can reduce 10 and 4, right? That becomes 5 pi over 2 meters. And so this is what I meant before by, let me make this a little more legible. That's a 5. It's 5 pi over 4. Or 5 pi over 2, I mean. Did I just make it worse? I don't know. This is what I meant before about radians not really being a unit. They're kind of just a label, it turns out. So even though pi over 4 had the unit radians, it was just a label. And the label we use on this one is meters, because meters is what 10 was measured at. So we don't actually include the radian value on that. Questions? All right, do this last one then. So this last one is asking to do both those things, right? So we're given a circle. Let me just draw the circle. The circle has a radius of 5 meters. And we're given the s value. We're given s of 6 meters. You guys see that okay? And we want to know what theta is. And we're being asked to show it in both degrees and radians. So you want to use this equation and solve for theta. But then that theta value is going to be in radians, right? So you'll do like dot, dot, dot. You'll get theta equals something in radians. And then convert this into degrees. You want to convert that in degrees by multiplying by 180 over pi. Questions? Does that sound okay? All right, let's take a minute and do that. topic for anyone? Does anybody want? Any questions? Yes, but that's a radian value, so it's 6/5 radians. So that's half the answer. With 100 degrees, we multiply that by. To go from radians to degrees. So notice how this was 100 radians to degrees. This was degrees to radians, so that's the fraction equals 4. What I was trying to point out before is it makes sense in this way because this radian, this rad, literally doesn't. Those three letters cancel those three letters. Left with 3. So that's why that makes sense. And the opposite is true in this, right? The degrees cancel left with the radian. You know what I'm saying now? All right, let's take a look at this one. So we've got an S value and we've got an R value. All right, so we can plug those in. This becomes 6 equals 5 times theta. And so then when we solve for theta, we get 6/5. Right, and so 1 1/5 radians is what that ends up equaling. Yes. Sorry, got scared that wasn't right for a second. That looks good though. So that's the radian value. And we know it's the radian value because when you solve this problem, you get theta in radians, right? That's what the top says. And if we want to change it to degrees, we take that value, 6/5 radians, and we multiply it by 180 degrees over pi radians. And again, the way you can remember the order of this fraction, just in case it wasn't clear, right? This fraction is the reciprocal of this fraction. This one goes from degrees to radians. This one goes from radians to degrees. And we can know which way the order is because the radians cancel here, and we end up with a degree value, right? So when you multiply 6/5 by 180, you might get 216 over pi. And we could divide that if we wanted to, and that would be approximately 69 degrees. And that makes sense, because 1 1/5 radian is less than pi over 2, and 69 degrees is less than 90. And so those two things seem to fit that picture and fit with each other. So that's good.
Same answer, but went the entirely different way.
Well, how did you think about it?
I figured out what times 5 equals 6, which I got 1.2.
Hmm.
and then I did 1.2 over 1 times 180 over pi, getting 216 over pi.
Yeah, so when you thought about what times 5 equals 6, you just solved this equation in another way other than dividing by 5, which is just as good. That's fine, but just know it can be hard to think about that sometimes. If it wasn't a 5, like if it was a 7 or something like that, that could be more difficult to think about. And so just note that dividing that over gives you the same thing too. But yeah, that's great. Other questions or comments? All right. Yes?
Would we have to do like 216 divided by pi like on the test?
I'm okay with leaving it like this. I'm just trying to make it something that's more familiar. And really trying to just drive home that pi is a number. Please don't forget that it's a number. It is a number. And so we can get a number out of there. But yeah, I'm fine with leaving it like that. I like this answer. And that's a more exact answer, right? When I wrote 69 degrees, I wrote these squiggly equal signs, which meant that I was rounding. And so this is not rounded. That's actually a nicer answer, in my opinion. But I just wanted to be clear what's going on there. Other questions? Okay. So that's one formula that we can use. Again, let's compare this one to the next one, because this one relates the radius, the length of the piece on the outside, the arc length, excuse me, and the angle. And the next one relates the angle and the radius again, but now we're calculating the entire area of that slice instead of just the outside piece or something like that. And so we have the same values of r and theta being in radians, so please let me just write that down again. Theta is in radians, please don't forget that. But this time we've got a formula that relates it to the area. And so we'll do kind of similar things on this one, except we're dealing with the area. So let's see what we got here. So we've got a couple pictures. Let's find the radius of each circle if the area is 12. So on both these pictures, we've got A equals 12. And we want to know what the radius is. So I'll just write in R here. We don't know what R is on either one of those. But we have a formula that we can use to solve it. What's the difference between these two pictures? What's the one thing we need to do differently in the two of them? Good. So the one on the left has a radian measurement. So this one's measuring the outside of this circle. The distance from one to the other, that is. And the other one is measuring theta, theta on the inside, which is 150. So it's measuring the degrees that are going on right there. And so on the second one, if we want to use this equation, we need to change it 150 into radians. That's the only difference between these two. The first one's not bad, though. So if we want to solve for r, we just plug it into this equation, and we have 12, because that's our area, equals 1/2 r squared times 0.7 radians. And we can just use the equation as is, because we have a radian value. And so just see what happens here. I'm just going to jump to the answer, but we multiply by 2 here, right? This would give us 24. And then we divide by this 0.7, so we'd have 24 over 0.7. And then we'd take a square root. And so we'd have r equals plus or minus square root of 24 over 0.7. And so this is approximately plus or minus 5.86. That doesn't sound right. Oh, that's probably right. Yeah, I'm sorry. That sounds right. So we get two answers, right, because we took a square root. But what's the answer we want? The positive one. Why do we not want the negative one?
Because it's great.
Adrian?
It makes no sense for it to be negative.
Say more. It doesn't make sense to be negative because...
Because like it's going like I typed it off right.
What is the value for? It's for the radius.
Yeah, it's positive.
So we can't have a negative length, right? Negative lengths don't make sense. Radius, this is a length measurement, and so minus 5.8 length is not true. And I know you guys are both saying that. I was just trying to get you to be a little more careful about it. Anyway, so we do r equals positive 5.86 because you can't have a negative length.
But also because it's squared, right?
But
No, I'm sorry.
you see what you mean, yeah. I heard you before, but I was like, oh, you could figure that one out. Yeah. We get the 2 because when you square it, it comes out. Yeah. Okay, that one's fine. The other one, very, very similar, but we're given it we're given 150 in degrees, and so this will be the last time that I kind of drive this home, or trying to drive it home. If we want to take 150 degrees, and we want to get something that says radians, then we need to cancel the degree and give us a radian. And so that means we want to multiply by pi radians and divide by 180 degrees, so that the degrees cancel and the radian sticks with us. Should have given myself a little more room here. This is actually one we know about, right? 30 goes into both 150 and 180, and it goes into 150 5 times, and it goes into 180 6 times. So this one actually is a familiar point. Didn't give myself enough room here. This is 5 pi over 6 radians. So that's one that's actually on the unit circle that we're familiar with. And so instead of using 150 in the equation, we just use 5 pi over 6. Right, but it doesn't carry any units with us, and so we don't use that unit. So anyway, we have 12 equals 1/2 r squared times 5 pi over 6. Again, I'll let you think about the algebra here, but we would multiply the 2 over to get 24. We multiply by 6. That would give us 144. And then we divide by 5 pi that is, and so we'd have 144 over 5 pi equals r squared. And so that means r equals, I'll do the same thing again, 144 over 5 pi. We get plus or minus again, because we took a square root. We only want the positive one, and so we just take the positive one. Right, what does a negative radius look like? I don't know. It doesn't look like anything. It's not real. Okay. Give the last one a go, unless there's a question about that one. Last one's very similar, and you're going to get to convert from degrees and radians again. You're just not given a picture, right? So we have an area of 10, so we were given a equals 10, and we're given that radius is 2. And so plug it into the formula, find one, convert it to the other.
That's weird because the dance studio is literally right underneath this room, I think.
And it filled up, I guess.
Oh, it's the overflow dance room.
It was like not real, it was like Cotton Eye Joe stuff.
Okay. Not a real dance crew then. Anywho's, let's look at this one. So we plug these in, we get 10 equals 1/2 times 2 squared theta. And when we go ahead and solve that one, right, we get 20, and then we divide by 4, and so we'll get 5 radians equals theta. And then if we want to change that into degrees, we want to cancel the degrees, cancel the radians, give it degrees. So we take the 5 radians, we want to divide by pi rads, because those will cancel, and then we want to give it the degrees by multiplying by 180 degrees. So these guys cancel, and this becomes something. I've got an approximate answer. This is approximately 286.5 degrees. And again, that should make some sense, because 5 all the way around the unit circle is 2 pi. All right, let's think about that real quick, just to be clear. That's t equals 0 and 2 pi in radians, and it's 0 and 360 degrees in degrees, right? And so 5 radians is almost 2 pi. 2 pi is, right, that's 6.28 about, right, pi times 2. So 6.28 is pretty close to all the way, 5 is pretty close to all the way around, and 286 is pretty close to all the way around in the other sense. Anyway, just trying to relate that stuff all together. Any questions about that?